Next, dairy products are concentrated liquid milk products. Concentrated liquid milk products, dairy products, there are two major categories. One is the liquid dairy products. The total solids is somewhere around 30 to 40% is the liquid dairy products. And the other one is the dried dairy products. Dried dairy products means the powders, less than 4% water, or sometimes according to the Sri Lankan standards, it's around 3% of less than 3% water. And liquid dairy products, there are two major categories. One is we call as the sweetened and unsweetened products. Sweetened and unsweetened products. Unsweetened condensed milk, unsweetened condensed milk, unsweetened all milk, unsweetened skim milk is available. And sweetened condensed milk, sweetened flavored all milk, and sweetened flavored skim milk. There are two types. One is from the whole milk, and the other one is from the skim milk. We can produce the unsweetened as well as the sweetened condensed milk. And another one is the condensed buttermilk, and the other category is the condensed whey protein, so we can condense, and the other one is the condensed buttermilk. Under the dried dairy products means the powders, full cream milk powder, skim milk powder, whey powder, sometimes the instant milk powder. There are many types are available in the market. In addition to that, there are other milk powders are available which are incorporated with the different kind of elements like things like aniline is calcium incorporated milk powder, and there are different names for the different age categories. It is available in the market. There are many names were there. And the pregnant mothers, there are special milk powders available. And then the why these are important, this the concentrated ones. So we can the benefits are that we can extend the shelf life of the milk. Now milk is converted into the concentrated milk powder, concentrated or concentrated milk, like sweetened or unsweetened, or milk powder. So when you convert into the different forms, so we can extend the shelf life. Now when you have the fresh milk, now the shelf life is around say a few hours, but pasteurized milk 3 to 4 days maximum. Sterilized milk, if it is in a bottle form, so it's a maximum 6 months, but once you open the lid, only you can keep it for several days after opening the lid. But let's take this the milk powder. Milk powder, sometimes the shelf life of the milk powder 6 months to 1 year. Another benefit of this is the convenience of handling. So reduce weight as well as the volume. We know that this fresh milk, if you convert into the milk powder, so then we from 7.6 liters of fresh milk need to convert 1 kilogram of milk powder. So then we can reduce the weight and volume. Product flexibility is there, flexible. Reduce transportation cost, weight and volume is reduced. Now transportation cost is we can reduce. Reduce storage. Supposing if we have this uh, 760 liters of milk, and if you convert into the milk powder, only you will end up with this 100 kilograms. 100 kilograms means is also the weight is lower than that of these 2 cement bags even, right? So then the reduced transportation cost. So reduce storage also. Now we need only very small area or the space for the storage facilities. But if we have the large volume, you need the large area. So this is the condensed milk. What is condensed milk? Condensed milk is one of the most concentrated form of milk, thick in consistency and having high nutritional value. It is widely used in several forms in our daily diet, particularly in confectionery products, confectionery, ice creams, preparation of desserts and other foods. You all know that this condensed milk we use for the confectionery product manufacturing process, ice creams, preparation of desserts and other foods. Condensed milk are products obtained by evaporating a part of the water of all minor fully or partly skimmed milk. Yes, it's evaporation is there. The main important steps are the evaporation. One is the evaporation, the unsweetened condensed or condensed, sweetened condensed milk. Evaporation is the major one. And uh, so this is the condensed milks are the product obtained by evaporating a part of the water of all minor fully or partly skimmed milk with or without the addition of sugar. If you add the sugars, then it is called the sweetened condensed milk. If you uh, prepare the condensed milk without sugar, then it is called unsweetened condensed milk. So the main objective of this manufacturing condensed milk is the preservation of milk. One is the preservation. There are benefits other than that. It's a kind of a preservation of milk. And the reduction in bulk for the purpose of long distance transport. Yes, I told you earlier also, the transportation is low. And the reduction in bulk for the purpose of long distance transport. And this is the preservation of milk is we can achieve by the controlling the growth and activities of bacteria through the selection of good quality milk. So at the time of receiving, we have to check the quality of the milk, and then the concentration of the solids of sugar to such an extent as will increase the osmotic pressure, which will increase when you add the sugars in the sweetened condensed milk, which will increase the osmotic pressure, and because of that we can prevent bacterial multiplication. So that's happening in the condensed milk. So it is a very uh, concentrated form of this milk. And the procedures for unsweetened condensed milk, you can see the clarification, standardization, and thermization. And most important step in the condensed milk manufacturing process is the vacuum evaporation, because this is a concentrated one. That's why condensed, concentrated. So vacuum evaporation is most important thing. And then the homogenization and sterilization, cooling, packaging, canning, and storage. Now you can see this is the production is the evaporation. Fall-in film evaporators are there. Then the homogenization, then the cooling, and then the another tank, and then the canning, and then the sterilization, and then storage. Or sometimes you can go for this the UHT treatment also, UHT treatments. So then the aseptic filling, even if you like, so you can have little bit cost is there. So UHT treatment. Otherwise, this is the evaporation, homogenization, cooling, and then canning, sterilization, and final product. Or sometimes UHT treatments. So then the UHT filling, aseptic filling. This is the unsweetened condensed milk. Manufacturing of sweetened condensed milk. So the procedure is, you can see this is the different kind of a procedure is there. And the condensed milk, I told you that the sweetened and unsweetened. Sweetened condensed milk also all milk, or by using the skim milk, we can produce it. Basically, the total solids is around 30 to 40%, and fat may be not less than 9% of fat is there. The sucrose, the sugar, addition of sugar is there. The next we'll discuss. Somewhere around 40 to 45% of sugar is added into the milk. So that's why we increase the osmotic pressure. When you increase the osmotic pressure, so the microbial multiplication will cease. And so those are the some of these the special characters of this condensed milk and sweetened condensed milk. So the sweetened condensed milk, now you can see this is the clarification. As you all know that once the milk receive it, by using the separator, the clarification, as well as so then the cream separation, so then after that standardization, so then the preheating, heat treatment is given. Pre-treatment is given, Because of this, the temperature is 85 to 90 degrees for several seconds, which will destroy harmful microorganisms. That means to ensure that the finished product is free from microorganisms and enzymes. Sometimes inactivate lipase or the protease like enzymes. So therefore, we have to give the pre-heat treatment, and ensure that the finished product is free from microorganisms as well as the enzymes. So then the decreases the fat separation and inhibit oxidative changes. The oxidative changes may be there. So therefore we can inhibit that, and decreases fat separation, may promote the defect age gelation. So may promote the defect age gelation. Later on we'll discuss under the cultured product what is age gelation, right? So I will explain it, and this is the one. And then in addition to that, the preheating, we can ensure uninterrupted boiling in the vacuum pan, to provide an effective means of controlling objectionable age thickening in the finished product. So we can provide an effective means of controlling objectionable age thickening, age gelation. So in the finished product, so we can control it. So that's why we have to give the pre-heat treatment. Sometimes the treatments can be in the even though 85 to 90 for several seconds. In some people, what they do is they use maybe around that particular temperature, maybe 5 to 15 minutes, or sometimes higher temperatures like 116 to 149 degrees for a 0.5 to 5 minutes temperature. So that is there. And then the evaporation is done. Evaporation is similar to the evaporation. Or then after that, the addition of sucrose, addition of sugar. So basically we use the sucrose, and sugar is added for the purpose of preserving the condensed milk without resorting to sterilization by heat. Sometimes by adding sugar, we can increase the osmotic pressure, and thereby we can prevent the growth of microorganisms, and as a result of that, we can extend the shelf life. So then we can, without restoring to sterilization by heat, so they can add, some people they use sugar. Normally the sucrose is added as it has provided to the most, it has proved to be the most suitable. The suitable one is the sucrose, and we had to use the highly refined cane or beet sugar. We had to use it. Sometimes we can use the other sweetening agents like corn syrup solids, glucose, and dextrose. So we can use other sweetening agents, but most of the time we replace sugar by 5 to 25% from these other sweetening agents. But there are certain disadvantages of these sweetening agents. They reduce sweetening capacity compared to the sucrose. They have the reduced sweetening capacity with compared to the sucrose, and sometimes the adverse effect on color. So when you use the other sweetening agents, they have the adverse effect on the color and the rate of thickening in storage. In the storage can happen if we use the other kind of sweetening agents. Rate of thickening during the storage is there. That is the most disadvantages of the other reducing sweetening agents, Normally, as I told you earlier also, sugar ranges from 40 to 45% in the finished product. We have to incorporate into the milk. So either it's a crystals or solution, but it's crystals generally, and that's the addition of sucrose. Then another important one is the most important one is the induced crystallization, induced lactose crystallization. That is another step followed by the addition of sucrose. So the reason behind this is the induced crystallization. So this is very important. Why? Because now we have in the milk we have the lactose, right? So therefore we have to, if the lactose present in the milk, sometimes it will give the different ones. So therefore we have to maximize the lactose crystallization. Otherwise it will give the sandy or gritty texture in a product. So that's why we have, by purposely we have to induce lactose crystallization. How we are going to crystallize this lactose? The condensed milk, after addition of sugars, the condensed milk, we have to cool it. So this is a very important step. We have to cool it. If the rate of cooling is not regulated carefully, the crystals of lactose form may be rather large. So the cooling is very important. If you don't control it, then the crystals of lactose form may be rather large, resulting in a gritty or sandy product. Yes, again the gritty or sandy texture is there. So that means the cooling is very important for the lactose crystallization. The chief aim is to regulate the cooling in such a manner that the lactose is crystallized into large number of exceeding small crystals. So the crystals are formed in the lactose. This induced lactose crystallization, we call as, there's another term that is called seeding. Seeding. So how we are going to induce the lactose crystallization? By introduction of lactose in very fine powder form during the cooling process to provide nuclei for crystallization. We can introduce small, very fine powder of lactose during the cooling. So then it will induce the lactose crystallization. That will act as the nuclei. So this, other than that, the crystallization, so we can achieve by adding spray-dried skim milk powder. Spray-dried skim milk powder, or sometimes small quantity of condensed milk from previous batch. Small condensed milk, portion of condensed milk from previous batch we can add, or fine powder of lactose we can introduce, or spray-dried skim milk powder we can incorporate in while cooling. So this is the standard practice for seeding or the crystallization, and adding a quantity of finely ground beta lactose or a quantity of cool crystallized sweetened condensed milk. It is the normal practice. Each added crystal constitutes a nucleus around which sugar in the product then crystallize on cooling. So because of that, the numerous these crystals form. Smaller the final crystals will become, so appear. So small ones will appear. Normally the product is cooled to almost 32 to 29 to 32 degrees centigrade and seeded. It is agitated vigorously at this temperature. Agitation also very important. Rapid cool while being agitation. Agitation is important. Vigorously we have to agitate at this temperature, or while being very slowly cooled to about 24 degrees centigrade. So it will take sometimes hours or so. So then after that, finally it will cool to 15.5 degrees centigrade or less with the continuous agitation. So this cooling and agitation should continue over a period of 1 to 3 hours. So then you will have the induced crystallization. That is the most important unit operation in the sweetened condensed milk. So just keep it in mind, sweetened condensed milk, when you compare with the sweetened condensed milk and the condensed milk, in the case of condensed milk, the evaporation is. And the sweetened condensed milk, the evaporation, then addition of sugar and induced lactose crystallization. So after addition of sugar, the evaporation is done as the addition of sugars. So then we have rapid cooling is there. While cooling agitation, so then we have to introduce the fine powder of beta lactose or sometimes previously prepared the condensed milk, portion of the condensed milk or spray dried skim milk powder. So then that the nuclei will form and maximum lactose crystallization is happen. So then we can prevent the sandy or gritty texture. So then after that, the packaging is the next unit operation. So we have the small containers like cans. It's commercial preparations. Now we know that this somewhere around 310 or yes 590 grams of cans are available. Or the large cans also they be there. And in Sri Lanka, the two companies are involved in the manufacturing of condensed milk. One is the Nestle, they produce the Milk Maid, and another one is the Highland, they produce the Milk Mite. Actually, the Sri Lanka government, they prepared this condensed milk in a Polonnaruwa factory long time ago. That at that time the name was we called as the Parakum. But later on now again they produce that is maybe the Milk Mite or something. So they have the sweetened condensed milk. Now this is the seeding or induced lactose crystallization. Now here the very clear four zones you can see. This is the white color area is called as the undersaturation area, and this is the point of this saturation point. And then this area is we call as the metastable zone or the area metastable zone. And another one is the nucleation zone. Nucleus was started. Nucleation zone or the labile zone. Another one is the precipitation zone. Precipitation zone is the dark color inside. And here the right side, by purposely we introduced the fine powder lactose in here. In here we introduce it. From here we introduce. Here the under saturation no lactose crystals, but once it comes to the saturation level, so we introduce the finely powdered the lactose here. But here this figure shows that no crystals were introduced in this here. So because of these two, how this nuclei forms. So this is the graphically present in this one. And first one is undersaturation. We all know that what is undersaturation is not reached for the saturation levels. And metastable zone, this metastable zone is this one. And here we introduce the crystals or without crystals. Metastable zone, critical supersaturation is not yet reached. So you can see not yet reached. Supercritical saturation is not yet reached. Therefore, there is no spontaneous nucleus. Only the added one or no added crystals were there, right? No spontaneous. So spontaneous nucleation does not occur. You can see spontaneous nucleus. You can see here in this area, labile or this the nucleation zone, spontaneous nucleations occur. But here, spontaneous nucleations does not occur. Heterogeneous nucleations are there, heterogeneous ones. But once it reaches the labile O nucleation zone, crystals appear spontaneous. Now crystals appear, even added ones surrounded by the crystals or without added crystals, so the spontaneous crystals are appear. And precipitation zone, precipitation occurs at very high supersaturation. Now precipitations occur at this level. Precipitations are there. But here you can see this is the spontaneous crystallization. This is called the seeding or induced crystallization, lactose crystallization. and it's graphically shown in this figure. Now the sweetened condensed milk, the first evaporation and then the homogenization, cooling. So then we have to add the lactose powders or the other slurry. So then crystallization, cooling, agitation is there, cooling and agitation, rapid cooling, agitation, you can see agitation is there. So cooling, so then you can prevent the sandy or gritty texture. And then after that we can canning and then we can have the packaging. But sometimes here the UHT treatment also be possible, or sometimes not UHT, so the paper boards like the packagings are there. We can pack in a paper boards. And condensed milk, the sweetened condensed milk, there are two processes. One is called the traditional process and other one is the modern process. Now in the traditional process, I have already explained it. Now if you prepare from the all milk, then pasteurization, then the evaporation, or sometimes you can pasteurization, we can add dry sugar, we can add it into the prior to the heat treatment, we can add it. So then evaporation, at this evaporation stage, we can sugar syrups may be added during the evaporation. Sugar syrups we can incorporate into during the evaporation process. So then the crystallization, the lactose crystals. So the lactose, we produce the small crystals, that is called seeding, and while cooling, so we can dry sugar may be added after evaporation also be possible in the more traditional process, either before heating, evaporation, or before after the evaporation we can add the dry sugars. It's possible, and then crystallization and packaging. But in the case of this modern process, we can prepare this sweetened condensed milk from all milk, or sometimes skim milk powder, full cream milk powder, butter, oil. Then we have to add water and reconstitution. So reconstituted concentrated milk is here. So then we have to add the sugar, addition of sugar, then homogenization, then pasteurized, and then crystallization process, lactose crystals were added, induced lactose crystallization or seeding, and then after the cooling and agitation is there, and then the packaging. This is the modern process. So again, the manufacture of condensed whey. Condensed whey means the liquid whey powder, whey is there. From that, the manufacturers, they produce the condensed whey. So we know that this the whey generated from the cheese manufacturing process as a byproduct, liquid whey. So the whey contains a lot of constituents were there: lactose, fat, beta-lactalbumin, alpha-lactalbumin, and water. So those are the major constituents in the whey. Beta-lactalbumin, beta-lactobumin and alpha-lactalbumin. Beta-lactobumin. The whey, we have the different names. One is we call the sweet whey or the whey. Another one is the acid whey. Whey or the sweet whey is the fluid milk product obtained during the manufacture of cheese. The casein or similar product by separation from the curd after coagulation of milk. We know that cheese manufacturing process, casein and some amount of fat will make it a curd during the coagulation process, and then products obtained from the milk. So that is the fluid milk. So by adding rennet enzyme, we induce the coagulation. During the coagulation, casein and the amount of fat will make it a curd because of the coagulation, and the rest of the liquid we call as the whey. That whey is we call as the normal whey or the sweet whey, because this coagulation is achieved by addition of rennet enzyme. But acid whey Acid waste, the coagulation is principally obtained by the acidification. Even coagulation is we can obtain by adding the acids, like we call as the vinegar, or sometimes we have the lime, lemon, or sometimes the billing juices, we can add it. So by adding these acids, we can reduce the pH up to 4.6. That is the isoelectric point. We bring down the pH. So then the coagulation is taken place. Because of the coagulation, now the casein proteins and the fat will coagulate it, make it a curd. And then the liquids are we call as the whey. That whey is we call as the acid whey. Acid whey. So sweet whey from the by using the enzyme rennet, the byproduct from the cheese industry, and acid whey means coagulation is mainly obtained from the acidification. Acidifications happen because of by adding acids, vinegar. Acid means from vinegar or lime, lemon, or Belin juices like things. So then it is called acid whey. Now, according to the Codex Alimentaris Commission, they have the Codex standard for the acid and the whey powder. Acid whey is the, you can see in the red color. The lactose in a whey powder is maybe the reference, the lactose is 61%. Even we call as the whey powder. The main ingredient is the lactose. And a milk protein, the minimum 10% in the case of whey powder, but in the acid whey, 7% of whey, milk protein, the minimum. Milk fat is the 2% is the reference, 2%. Water, 5 is the maximum in whey for the sweet whey, 4.5 in the acid whey. Ash content, 9.5 is the maximum in the sweet whey or whey, and 15 in the acid whey. pH is the minimum pH is less greater than the 5.1 and not significant in the acid whey. Maximum 5.1 in the acid whey, but maximum value is not significant in the whey powder or the normal whey. But anyway, just keep it in mind, even though we call as the whey powder, milk protein is the minimum 10, or the in the acid whey is the minimum 7, but major ingredient is the lactose. So the packaging is traditionally we can pack in a cans, I told you earlier also, 310 and 590 grams cans, or paper boards like beetroot barrels, sometimes paper board packages, aseptic packaging, so we can use for this packaging. Then the next one is the concentrated milk products, is the we call as the powdered milk product, powdered one. So here we have the different forms of the milk powder. Dehydration refers the removal of water. Can you remember that dehydrated powders? Now, initially, if you use the fresh milk, so the water activity of fresh milk is somewhere around 0.993. But in the case of this dehydrated form, the water activity is less than 0.6, because most of the water we remove from this during this dehydration process, right? So in according to the Sri Lankan standard, the maximum is 3% moisture, but Codex is given till up to 5%, and thereby we can reduce the water activity. If you can control the water activity less than 0.6, most of the microorganisms cannot survive in these water activity levels. Specifically, the specific osmophilic organisms, maybe the fungal-like organisms can grow, but very rarely. Different type of powders are available: full cream, instant milk powder, skim milk, whey powder, and other forms, as I told you, that incorporated with the different elements, so the aniline-like things, or even the pregnant mothers, specifically for the pregnant mothers, or some powders specifically for the different age groups. There are different milk powders are available: elderly persons, or the peoples are having the different diseases, so then the special kind of whey powders are there, so sometimes a little expensive. Now milk powder, the depriving microorganisms of the water necessary, that's why I told you the water activity levels are reduced. So this has been practiced for centuries. Reduce water content into 2.5 and in between 5%. That's why I told you in Sri Lanka 3, but in the Codex 5. No microbes growth occurs at this water content. Microbes cannot survive because the water activity is less than 0.6. And we can increase the shelf life. Full cream milk powder, maybe maximum 6 months or 1 year, sometimes 1 year. Skim milk powder, sometimes maybe the 3 years. Otherwise, the oxidations can happen during the storage. So that's why you all have noticed that this, if you open the milk powder into the environment, so then after that, you just try to take the 1 or 2 teaspoons of milk powder and try to make it a tea. So it won't dissolve it, because if it is oxidized, it can form different compounds. Sometimes different amino acids will react in the different way with this light and the oxygen, so it form different compounds, and the deteriorations in taste is there. So that will happen. So therefore, we have to keep it in aluminum like foil, and internally the inert gas is there, and prevent the entering of light as well as the air. So that's why once you open the pack, you have to keep it in a tight container. So various uses of milk powder. So milk powder we can use for the different purposes. Recombination of milk, yes, we can recombination of milk, we can use it. And in the bakery industry, sometimes we can use it. And increase the water binding capacity, milk powder which will have the ability to bind more and more water. So then increase water binding, we can incorporate. Mixing into the pastry dough to make it crisper. Chocolate industry, sometimes the sausage manufacturing process as a binder, we can use milk powder. Using ready cooked meals as a substitute for mother's milk, yes. So sometimes the young infants, instead of having this mother's milk, we can use the milk powder as a substitute. Production of ice creams, milk powder. Or not only that, even in the yogurt manufacturing process, some manufacturers, they totally depend on the milk powder, ice creams and yogurt, and production of animal feed. During this manufacturing process, some residues, some maybe the waste are generated. So therefore, milk powder we can use for such kind of a milk powder we can use for as animal feed. There are many uses in the milk powder. Proceedings is as initial unit operations are almost similar. Clarification, standardization, and thermization. Then here also there's a very important one, vacuum evaporation, or we call as the concentration. Concentration before drying. Concentration. Now we know that in the milk which contain around 87% of water, but if the milk directly, if you send it to the dryer, drying is mainly from the spray drying process. If you directly send it to the spray dryer, so then you need a lot of energy and heat to evaporate this much of water or the moisture. But to prevent that, so before send it to the spray dryer, the milk, fresh milk will send it to the vacuum evaporation or the concentrations. We call as the concentration, like falling film evaporators are there. So then initially 87, now it's reduced the amount of moisture, maybe around 40-45%. So then concentrated milk will send it to the spray dryer. So thereby we can economize, we can reduce the cost from this step. Evaporation therefore is very important in the milk powder process. And the drying, then packaging and storage. Drying is the main one. The common dryers, they use the roller dryers. But in the case of milk powder, where normally we don't use this roller dryers, but roller dryers also, you are aware of that there are different roller dryers were there, double drum, single drum, twin drums, or the spraying mechanism by using the spraying nozzles, or by rollers we can spray and then dried powder will collect it. But in the case of the milk, normally very rarely we use the roller dry, but most common one is the spray drying system. So spray dryers are the most widely used. Drying take place maybe within a few seconds. One is the two phases are there. One is the concentration of milk by evaporation. That's why I told you. Maybe falling film evaporators are used. So by using this, we can remove the excess water. And dry matter content is around, initially milk is around 13, now it's around 45, 50, 55% of dry matter. Moisture is reduced up to the low levels, half levels, relatively fast process. So then the dry in the spray tower. In the spray drying mechanism, so the concentrated milk will send it into the dryer and disperse this concentrated milk into the very fine droplets. So by using the atomizer, atomizer is there. So by using the atomizer, it will spray it into the small droplets. Then it will mix and disperse this one into the steam or the hot air. Then hot air is blown into the spray dryer tunnel. Hot air is blown. So then the finely dispersed this droplet will mix with the hot air. So then the separation of dry milk particle from drying air is happen because we can collect it from the bottoms. The cyclone is there, so the powders are collected from the bottom. Now this is the drying process. There are many dryers are there, spray dryers. One is called the single stage drying process. Now this is the concentrated milk tank is there, and this is the drying chamber, and this is the air, heated air, dry air, heated air is blown into the inside the tank or the drying chamber. Then this is the atomizer. Atomizer is the one which will break this concentrated milk into the small droplets. This is something similar to the in bathrooms. We have the shower is there. Water comes and then it will atomize, break it into the small droplets in the shower. Likewise, here the atomizer, very fine particles, break it into fine particle droplets, and then spray it into this drying chamber, and then mix with the dry air. So then this is the main after mixing, then it will blown into this the cyclone, or sometimes the certain ones will, the powders are there, then powders is very collected, and then again finely dispersed powdered like particles from the cyclone we take and then collect it from the bottom, and then after that it will just pass it through the system of the cyclone, and they collect the powders. Powder will collect it from the bottom of that. And this is called the single stage drying. In the single stage drying process, the disadvantage of this, which contain little bit high amount of moisture in a powdered milk. So therefore the scientists, they have introduced two-stage drying one. The first stage drying is almost identical to the single stage drying. And in addition to that, there is another drying that is called the fluid bed dryer is there. After sending through this the single dryer, so then the drying process, the milk powder will send it from the fluid bed dryer. So from the fluid bed dryer, so then the single stage, the cyclones, the milk powder is collected, and again milk powder, this powder, fine powders, as well as they comes from the single drying, pass it through the fluid bed. And when you pass it through this fluid bed is another drying process, and finally the powder will collect it from here. This powder contain less amount of moisture with compared to the single stage drying process. That is the advantage of having the two stage, the fluid bed dryer. And again, the scientists, they have developed another spray drying system. This is we call the three-stage drying process, three-stage. And you can see this is the atomizers were there and sprayed. Heated air is enter into this chamber. Drying air distributor is there. Then the air is distributed, heated air. And this is the primary drying chamber. Almost the primary drying chamber is there. Then the retention chamber is there. Again, heated chamber, retention chamber. And then another drying chamber is there. Drying chamber. And then the cooling chamber is there. The drying, retention, again another drying, final drying, and then the cooling process, and powdered milk will collect it from here. That the powdered one will collect. This is called the three-stage drying. Three-stage drying. So retention time is there sometimes, so then we can control the moisture levels in the final product. Now, according to the Codex standard, so they have specifically mentioned about this cream powders. Minimum milk fat is 42, water is 5%, and milk protein in milk solid non-fat is 34, is the mass by mass in the cream powder. All milk powder, milk fat is minimum 26 and less than 42, minimum 26. That means if we have the 3.5%, so 3.5% is concentrated 7.6 ratio. So then it is 26 is the minimum. Maximum water is 5 is the codex, but in Sri Lanka 3. Minimum milk protein, milk solid is 34%. Partly skim milk, so skim milk without fat, more than 1.5 and less than 26. Skim milk powder is a maximum is the 1.5 maximum. This is the maximum one. Maximum water also 5 and milk solid non-fat is 34. Partly skim milk 1.5 to 26. Skim milk 1.5 is the maximum, and all milk powder milk fat is 26 to 42. Even yourself you can calculate this 20 how this 26 comes. 3.5 into 7.6 sometimes. So because we need the 7.6 liters of milk to make it a 1 kilogram of milk powder, then it's around 26. So in addition to that, they recommended certain additives in a milk powder. The stabilizers maybe they recommended, firming agents like potassium chloride, calcium chloride, acidity regulators. There are many acidity regulators for there. Emulsifiers, lecithin. That's why they incorporated with the lecithin and they produce this instant milk powder. Lecithin is there in the instant milk powder. Or mono and diglyceride of fatty acids are there. The same kind of emulsifier. And anti-caking agents are there. Anti-caking. Caking means we all know that it forms some sort of a lumps. Lumps are formed. Aggregation of particles because of the moisture, and then the lumps are formed. That is called caking. Anti means against caking, against lump formation. So therefore we can add different kind of agents like additives, recommended ones. So then it will prevent the anti-caking. Quickly it will dissolve it. And antioxidants are there. Butyrated hydroxyanisole, BHA 320, ascorbyl palmitate, sodium ascorbate, ascorbic acid. So those are antioxidants, recommended antioxidants, and you can see the maximum levels are given. So that's all for this the concentrated milk products. So then we have to discuss the cultured milk products.